All right, everybody. Number 16, part B. Like I said, I'm not going to do all of 16. I'm just going to do a few. The first thing you're supposed to do is write an expression for Kc for the following reactions, and then indicate if they are homogeneous or heterogeneous. For this particular reaction, this is our reaction? Yes. Oh. Thank you, ma'am. Oh, that makes sense. All right, so first things first, homogeneous or heterogeneous? Heterogeneous, right? Because, why? Has more than one phase. All right, and the expression, which should only include gases or aqueous solutions, should be that. If there's nothing in the top or the bottom of a fraction, you put a 1 in. Okay? So that was B. I'm going to do F next. F has 2. This is my expression, so homogeneous or heterogeneous? Heterogeneous, why? Because there's that liquid at the very beginning. The K you should write is going to be the concentration of the products divided by the reactants. In this case, I've got CO2 raised to the power of 16, H2O raised to the 18th, all divided by O2 to the 25th. And you'll see that C8H18 is not in my expression. Okay?
So,
yes?
number in front, that becomes
That becomes the exponent, yes.
Okay.
Raised to the power, the order, if you will. Okay? All right, moving on to number 18. We were asked, which of the following reactions lies to the right, favoring the formation of products, and which lies to the left, favoring formation of reactants? For this, you don't even need to look at the reaction, you just need to look at the K values you were given. This one a KP? Oh, this is KC. That first one was 5 times 10 to the 12th. The second one was 5.8 times 10 to the negative 18th. One of the things we learned yesterday was about K values and what they indicate. So if your number is very, very big, then it's what? Product favored. So you'll see this stated in several different ways moving forward. One thing we can say is it's product favored. Another thing we can say is that mostly products are formed, or mostly reactants are formed if it's reactant favored. You'll hear terms like lies to the right or lies to the left for equilibrium. If it says lies to the right, it means product favored. If it means lies to the left, it's reactant favored, et cetera, et cetera. So there's a couple of different ways you're going to see this terminology. Okay. What about this one? Since it's so small, negative exponents mean reactant favored. Okay. The next one was 24. And we seem to do okay with A, but C tripped us up a little. And we're going to talk about it. What's up? What'd you say?
the whole problem.
Oh.
This is not good.
First things first, we're going to start with the equation. We were given 1.08 times 10 to the 7th at 700 Celsius, which equals what in Kelvin? Don't forget that R is 0.08 to 06. The equation we should use for this is the one we introduced yesterday that says Kp equals Kc times RT to the power of delta N. And in calculating delta N, I'll remind you that it's moles of the product minus moles of the reactant. And we could take this just a step further and say total. Okay? So total moles of the product is going to be the total molar equivalence on this side, which in this case is 2. On the left side, we have 2 plus 1 is 3. So delta N is -1 for this particular reaction. That's how we get delta N. Some of us seem to get tripped up there. And in part C, we change this number here from a 2 to a 1. So delta N changes to a 0. We'll see how that happens in a second. All right, so plugging in our numbers. R is 0.08. Oops. 206 times T, which is 973 Kelvin, to the -1. Please remember that this is the thing that gets raised to the power. So when you're putting this in your calculator, if you just kind of straight typed it, you might get a different answer than the rest of us. Okay. And I saw big numbers. Should your number be big?
No.
Are you sure? Think about it.
Oh, no, it should not.
Well,
Yes, no,
is
maybe.
Kc, I guess the question is, the initial information you're given, is this product or reactant favored? That number's big, right? That would mean product favored. In converting from Kc to Kp, do we change how equilibrium lies? No. Kp should still indicate product favored reaction. So Kp should still be a bigger than 1 number. Right, times.
I feel really dumb. I calculated the actual moles for every single one. Like, I calculated the moles for each two.
I got Kp to be that
Yeah.
6-figure number, still pretty big. 1.4 times 10 to the 5th is pretty big, not as big as 1.08 times 10 to the 7th, but still a product favored reaction, right? So that's what I got for A. For part B, it says, which is going to be mostly created, the products or the reactants? The products. Okay, so B is products because, so don't just say products, tell me why. Because Kp and Kc are much, much greater than 1. Okay, all right, so for part C, things change a little. For part C, it says, what happens to Kp and Kc if we change the 2 in front of the H2 to a 1? So our delta N now becomes a different number. Our total number of moles on the right is 2 minus 2 means delta N is 0. Okay? So in this overall equation that we use to go from Kp to Kc, because we still have Kc, Kc shouldn't really, not something we can really change at this point. What happens here? This whole thing gets raised to the delta N of 0, which means 1. So they're equal. It says, what happens to Kp and Kc? You say they're equal. Because the molar change in moles is 0. It takes out this whole term. It means Kp and Kc stay the same. That was part C. Could you have done math on it? Sure, you could have just said that Kp equals Kc and Kc is 1.08 and 10 to the 7th. The whole idea was for you to see that Kp and Kc would then be equal. All right, let's do, well, this was 24. Now we're on 28, right?
Yeah.
right, for 28, you were given an equation. Oops. Of this. It says, what is the Kp for this reaction? If there are two steps, okay, there are two other equations that are added to get this. The important information are, I'm going to have to eventually calculate Kp, and that this reaction is done at 298 Kelvin. Okay. Next thing is we want to write out the two equations we have. So the first one, we were given Kc equals 20. In the second one, we were given Now, yesterday we talked about how Hess's law says we can add two things together to get a goal reaction. Yeah. What did I say? Huh?
The first Kc is moved 2.0. Yeah.
Is it 2.0?
Yeah.
Yep. Did I screw anything else up? Okay. Hess's law says we can add two equations together, and when we add those two equations together according to the equilibrium system we talked about yesterday, we multiply the k's together to get the final k. First question, can I just add those two together to get that goal reaction on the top?
Yes.
No.
No. No, you cannot. If you add these two together, you get NO on the left side. NO is not present in this original reaction that we're going for. And you get O2 and N2 on the right side as products, not what the goal reaction says. So you have to do something. What do you have to do? You have to flip the second reaction.
Well, could you technically flip the other one and then just reflip the entire thing?
Yeah, you could. You could flip either one, obviously. But then you'd have to flip it all again, so I wouldn't. I would just flip this one. In flipping, we rewrite. What did lecture say we do to K's when we flip reactions? We take the inverse. So Kc is going to be equal to 1 over 2.1 times 10 to the 30th. So Kc for that particular second step becomes a negative number, correct? Or becomes a very small number.
Very small.
Remember that when we flip reactions, the side they favor also flips. So originally we wrote that second reaction so that it favored the N2 and O2, right? You see the big number for K says this is a very, very product-favored reaction. When we flipped the whole thing, it still has to favor N2 and O2, and the value for K should also reflect that. So what does our K become for that second reaction then? We do 1 over 2.1 times 10 to the 30th, and we get what?
4.762 times 10 to the negative 33.
Very, very reactant favored. Okay. Now that we've done that, can we add the two together? Let's do it and make sure we actually get the goal reaction. Should be our goal. When we add them together, what do we do with K's? Not add. Multiply. Ah! Okay, so when you multiply them together, what'd you get? on it. All right, hold on. 9 point.
5, 4, 5 10 to the negative 3.
Okay, are we done?
I don't know.
God, no.
Heck no, we're not. What were we asked for? Yeah.
She said 524, I think.
Okay. But we were asked for KP, right? Is this KP?
No.
That's KC. How do we go from KC to KP? We still have to go to KP. So we need to take our KC value and we need to convert it using the equation that converts from KP to KC. I know. Most of us do. R is 0.0826. T is 298. Ooh, what's delta N? 2 minus 3 is negative 1. I highly recommend when you do these conversion problems that you do this thing first, raised to the negative 1, then multiply whatever the product of that is by the KC value. Okay, don't just like try to straight type this in your calculator because it will screw it up. What do we get for an answer?
3.89 times 10 to the negative 30.
Oof. So 3.89.
Times 10 to the negative 32nd power.
Should do it on your own to confirm. All right. Let's do some more. Oh yeah. We're never done in chemistry. All right, let's do another one. So we're gonna do another one like this, given information. So here's our goal. I'd like you to do it on a piece of paper, but I ask you to turn it in before you leave.
Can we do it on the homework back?
Sure. So,
There's no cobalt in that information.
I'm not done yet.
Yeah.
To make sure I don't miss decimals. And bless you. Okay, so 2 questions. First is what is KC? Second is what is KP? Okay. Oh, that's cobalt. Is that what you're asking? Yeah, cobalt is in both reactions. It is not in the overall reaction.
So that
You're going to have to manipulate the steps to get rid of it.
the number 2
Mhm.
is the O.
Is that when you like
What
look at
is
pretty bad?
Oh, that's gas. Sorry.
No,
That's a good question. What's up?
Is that when you flip it?
Yep. Manipulate means flip. If you flip, remember what to do to your exponent, or remember what to do to your KC. When you flip, what happens to KC? You take the inverse.
So put it under one.
Hmm?
Put it under one, right?
Yeah. So 1 over it. That's right.
I don't know what to do. I wasn't thinking about it.
So how do we get the things we want on the right side? So that one needs to be on the left side, right? So we need to do that second equation. Yep. I would say since your goal is to put your goal is to make exactly that same reaction at the top. So yes, it matters which one I flip. Make sure you know that that's important. Yeah. Yeah, I'll look across them too. All right, so now add them together and see what our points on the sides, okay? Please be careful, don't get lost with CO and
How many decimals do you want us to? 4,
V.
right?
Let's go with 3 sig figs.
No.
I don't know what that means.
So then that would be
Well, if your number, well, here's the thing is if you get a really, really small number like 0.0002, if I say round to 3 decimals, you're gonna have no decimals.
So what do you do? 10.
There you go. I like scientific notation.
I'm just
If it's a
gonna
small
give
enough
you
number, put it in scientific
So
notation.
you want me to just leave it like this? I'll just run it through.
Huh?
Sig figs!
No.
Sophomores don't complain about sig figs.
Wait, well, the sophomores,
I make them use them every single time.
the sophomores are sophomores. And they
Stop
shouldn't
it.
complain about sick days.
This is the last question. This is your exit ticket. Upload it when you're done. Have a great day.